Pre-Calc students, Coach H here with your Chapter 2, Section 3B notes. Yesterday, through a video, we reviewed long and synthetic division and just the processes of those. Today, we want to focus in on synthetic division and the uses of synthetic division, kind of two ways that synthetic division can help us out here in pre-calculus. So one of them is just kind of interesting. The other one will be much more important when it comes to moving forward here in Chapter 2. All right, so let's get into those. We're going to talk about a couple of theorems here, all right? So the first theorem that we want to cover is what's known as the remainder theorem. And the remainder theorem says if we have a polynomial and we divide it by x minus k, right? That's the only situation in which we can use synthetic division. Then the remainder of that division is equal to f of k. So the meaning of this is when I use synthetic division, the remainder that appears would be the same thing that I would get if I were to just plug in our k value to our function and evaluate it just algebraically. All right? So we'll take a look at this today and kind of explain through an example what we mean by the remainder theorem. Okay? The other theorem that's going to be important to us is what's known as the factor theorem, right? And if we think about, hey, if f minus k, if we plug that in, that's f of k, all right, and that gives us the remainder. Well, we need to think about what if we plug in k and what we get out is 0, right? Well, what that would mean is whatever we just use for k in our synthetic division is we've just found a 0 of that function. So if the remainder is 0, that means that x minus k is a factor, right? So earlier, or yesterday I should say, I mentioned how we will use synthetic division to help us factor, and it's this theorem that helps us do that. So we're going to take a look at that today through an example problem as well. And then as always, we'll give you a homework assignment to get a little practice with, all right? So let's begin with the remainder theorem and an example of that, all right? So if we had some function, right, f of x is equal to 3x cubed plus 8x squared plus 5x minus 7, and we wanted to evaluate f of a negative 2, right? Well, we could do this algebraically, right? So I could come up here and I could just plug in a negative 2 for x. All right, so let's start the kind of the long way, all right? So if I just plug in negative 2 for x, right, this is f of negative 2. So I do my math work here, right? Negative 2 cubed is a negative 8. And a negative 8 times 3 is a negative 24. All right, then over here we'd have a negative 2 squared, which is 4, times 8 is a positive 32. And then a negative 2 times 5 is a negative 10. And then we have minus 7. All right, so if we continue to simplify this down, right, we're going through all the algebra work, right? Well, as we, if I add up all my negatives, I have a negative 34, negative 41, so a negative 41 plus 32 would give me a negative 9. And this would be the value of f of negative 2, okay? Now, that's not hard to do. But if you stop and think about it, like that took us a little bit of work. I had to do a little mental math. You know, I'd think about cubes and squares and all that. Well, what the remainder theorem tells us is if I just use synthetic division, so I put a negative 2 in the box, and then I go ahead and fill in all my coefficients, right? Remember, anytime we do synthetic division, we need to fill in zeros if there are any terms missing, but we don't have that in this case. So I'm just going to list out my coefficients. So 3, 8, 5, negative 7, and I go through my process of synthetic division, right? So I drop the 3, I multiply it by a negative 2, I go ahead and add, multiply it by a negative 2, go ahead and add, multiply it by a negative 2, go ahead and add. Well, look at that. The remainder is the exact same value as if I evaluated f of a negative 2. And that's what the remainder theorem tells us, right? So if you're asked to evaluate a function, we can use synthetic division to quickly evaluate that function, all right? And that's just a pretty helpful little trick. So just something to kind of keep in mind, all right? So again, that's an example of our remainder theorem, all right? So now let's talk a little bit about the factor theorem, right? We said, hey, if you do this synthetic division and the remainder comes out to be 0, well, that means then that you found a factor of our polynomial, okay? So let's use synthetic division to help us factor. Now, we're going to kind of baby step our way into this. Eventually, I will give you a function like this, and I'll say factor it, but I won't give you any factors. Today, we're going to start by giving you some factors, okay? So let's begin with the x minus 2, since that's first, all right? So if this is a factor, if I divide that into this function, I should get a remainder of 0, all right? And so let's check that out. So x minus 2, so my k value is a positive 2. Right now I'm just going to go ahead and list out my coefficients, right? Check and make sure I don't have any zeros I need to fill in, right? I got to the fourth, to the third, to the second, to the first, 0. All right, so my coefficients are 2, 7, -4, -27, and -18, okay? Now again, I'm told that x minus 2 is a factor, all right? And so when I get done here, I better end up with a remainder of 0. So let's see if that plays out, right? So I drop my 2 down, multiply it by 2, add these together, right? Go ahead and multiply. So 11 times 20 or 2 is 22. I go ahead and add, get 18. 18 times 2, 36. 36 minus 27 gives us a positive 9. 9 times 2 is a positive 18. And we end up with a remainder of 0. All right? So we have just showed that x minus 2 is a factor. Right? Now we also need to show that x plus 3 is a factor. Now, the cool thing about this is we can now work with these coefficients. These would be what's called a reduced polynomial. So we've reduced our original polynomial by one of its factors. So I don't have to go back and start over. I can pick up right here, right? So if x plus 3 is a factor, that means k is a -3. So I can just stack my synthetic division right underneath my original synthetic division, right? So now I drop my 2 down. 2 times -3, -6. Add those together, get a positive 5. That gives me a -15. Add those together, I get 3. 3 times -3 is -9. And I end up with 0. All right? So now at this point, those are all the factors we're given, but we're not done factoring this yet, right? Both of these factors resulted in a remainder of 0. So right now what I have, if I'm factoring this, is I have x minus 2, right? That was a factor I was given and checked, times x plus 3, right? That was a factor I was given and checked. But now I need to think about what my reduced polynomial is, right? Well, remember we started with x to the 4th. So we took x to the 4th and divided it by x minus 2, right? So that reduced it down to x to the 3rd. And then I divided that by x, so this is reduced down to x squared. So I can write my coefficients now as the reduced down polynomial. It's 2x squared plus 5x plus 3. All right? And now I just need to factor this further. Okay? So if I factor this as a trinomial, right, I got 2x squared times 3. This is going to factor into 2x plus 3 times x plus 1. All right? Get my parentheses there. And if we multiply these back together, right, 2x times x, 2x squared, 2x times 1 is 2x, 3 times x is 3x, 2x plus 3x, there's my 5x, 3 times 1 is 3, I've got it factored, right? So now the complete factorization of that original polynomial would be x minus 2 times x plus 3 times 2x plus 3 times x plus 1. All right? And you can see how we use synthetic division to help us fully factor that polynomial. And that's going to be an important skill for us as we move forward in Chapter 2, is the ability to quickly and efficiently use synthetic division, because again, we're going to use that to help us factor. All right? So that is our Chapter 2, Section 3b notes for the day. Again, just using that remainder and factor theorems. Pretty simple things overall, but again, we're going to use them as we move forward. So here's your homework assignment for the day. If you have any questions, feel free to chat with a classmate, rewatch the video if need be, or wait until I see you again and you can ask in person. All right, you guys make it a great day. I will see you later on.